Hi, everyone. Welcome to our first AWS Partner Global webinar. We're super excited to see all of you today and to talk a little bit about how we've been partnering with AWS, specifically in the Gen AI space, to build out some really exciting solutions for our clients. So by way of introduction, I'm Mal. I am the president and chairman of the board here at Zeb. And with me today, I have Francis Dogby, who is our amazing AWS partner point of contact. And he's been super amazing in helping us put all of this together. And then also from the Zeb side, we have Ranjit Nagesh. He is our head of data strategy, as well as Sid Vivek, our head of AI solutions. So with that, we can get started. And we'll begin by telling you a little bit more about Zeb and who we are as a company. So at Zeb, we are a leading digital transformation strategy company, and we're incredibly excited to be an AWS Advanced Tier partner. We really partner with a lot of our enterprise clients across various industries, from logistics to retail to fintech. And really partner with them to understand what drives operational business value for them and how we can use technology as the enabler to do so. A lot of our clients are at different phases in their digital transformation journey. And often, it requires a really deep partnership as well as a really deep understanding of their business and their business methodology. One of the main unique things about us is not only do we partner with the technology stakeholders of businesses, we also partner directly with business stakeholders because we believe that by connecting the two sides, that's how we can really drive true value from technology. We have over 15 years of experience as a company in this space, and a great team of over 1,000 technologists based in Chennai, India, as well as the US and Canada. So with that said, we'll jump into a little bit more about our key strengths as an AWS partner. So as I mentioned, we're very excited to be an advanced tier partner. And with that comes a lot of what we like to call superpowers in the AWS space. The first one is we've had the experience of dealing with a lot of really big enterprise complexity in a lot of our projects. And what that means is, several enterprise clients, like I mentioned, are at different phases of their journey. And usually that leads to a multi-tenant architecture, several different applications that may or may not be connected. Often we're dealing with both an on-premise presence as well as a cloud presence. And we need to really bring the experience of being able to seamlessly connect those infrastructures. And we've done that several times in a lot of our previous projects. Another key superpower is our ability to handle high volume migrations that may or may not also be coupled with data transformation. So one of the things you'll see in the demo we're going to show you a little bit later today is how that plays a very key role in creating the foundation of building AI solutions. And so we've had to handle several large scale, both online and offline data migrations as well as syncs. And we've utilized services like DMS, but we've also used some of the more niche services like Snowball in helping enterprise clients move off on-premise solutions. Then the most relevant superpower to this demo is our custom and pre-built AI implementations. And these allow us to initiate a very rapid Gen AI prototyping phase with a lot of our clients. Sometimes it can be just between 2 to 3 weeks, where we can really identify where AI could be a very natural fit with their existing business processes and platforms. And this has been the most effective way to manage change as they progress into AI as a solution, because we're not changing the way that they work, we're just enhancing it and building on top of it. The last piece that's a very key strength of ours is serverless cloud transformation, which is kind of the connected thread through the first 3 superpowers, where we're really modularizing existing application architecture. And again, this could be on-premise, it could be in the cloud already, but one of the key aspects of difference we take is a phased approach to this. And what that means is, again, change management is a huge concern with a lot of our clients. as they begin their digital transformation journey, or even if they're in the middle of it, they want to make sure that we're being, the least amount of disruptive as possible to both their internal employees as well as external customers. So one of the key things we're able to do is move things in a modular manner, creating the least amount of disruption to the business while still giving them incremental improvement and constant value. With that said, I'll turn it over to Sid, and he'll talk a little bit more about the AI accelerators that you're going to see at play here in the demo we're going to show you.
Yeah, thank you, Mal, for that introduction. And as Mal already slightly touched upon, our accelerators are what really allows Zeb to deliver in the speed in which we do, while maintaining quality up to standards. I wanted to talk about 3 core accelerators that really drive all our implementations that we're working on today. And we'll even use one of them as a case study that we're going to go over in this call. The first of that core accelerator is our AI-driven data accelerators. This includes accelerating data discovery, integration, and data transformation tailored for business-specific use cases. When looking at specifically data discovery and how to accelerate that by automating that, usually data discovery requires extensive manual effort to scan and catalog all the different data sources companies and organizations use. But with the power of AI, we've been really able to automate and completely take away the manual process in this effort. Oh, and when looking at data integration, we're able to significantly streamline timelines, reduce errors, and also facilitate faster extraction from various data sources. And then when finally coming to data transformation, this is where it gets a little bit different, as data transformation from our past experience is not a one-size-fits-all, and it really adapts to the business industries that we're working with. And over the course of our 15-year journey, we worked with several different business industries, as Mal mentioned, some of those being retail, fintech, logistics, and so many others. And with that, we basically templatized the digital transformation we do, the data transformation we do in each of those industries, and made an automated process fit to that business and with a very specific use case in mind. With the next core accelerator is our AI-powered SQL and Python codegen. This accelerates the data development with AI-enhanced SQL and Python codegen. And while we know there's multiple different codegen tools on the market, what this accelerator really does different from that is the prompt engineering approach it takes. Well, other codegen tools usually involve users having to go through an iterative format with either trying to fix the response that comes back from the LLM or trying to figure out the best prompt to get the best output. The approach we took was slightly different. By instead of having the user trying to come up with the prompt, we specifically asked the user fields around the requirement that they're working on, and then with that, put those details inside our in-house prompt engineering framework, which then delivers the best prompt for that use case, getting them the result they're expecting on the very first try. Lastly is our AI-powered reporting engine. And this is where we really harness the power of AI to analyze data, uncover trends, and provide actionable insights for informed decisions. This reporting engine takes users' requests and turns them into reports in a matter of minutes. Beyond that, it can also compare reports individually, comparing maybe a Q1 report with a Q2 report and identifying anomalies within that, and then based on the context that it has, provides actionable insight as to why these anomalies have occurred and how we can actually take, what actions can we take upon them. This accelerator is what we really wanted to talk about in this call and use it as a case study, but specifically how we implemented this accelerator within a logistics industry, which had a large backlog of reports that had 2 dedicated data analysts working on it. But we'll speak a little bit more about that in the future. Before that, Ranjit is going to cover our key focus areas that Zeb revolves around.
Thank you. In Zeb, our key goal is to bring operational efficiency in our existing customer and also to identify new opportunity to increase their revenue by looking at the data pattern. In doing that, we have aligned our key focus area, tailored specifically to achieve that particular goal. Our first key focus area is like a app database modernization. Part of our app database modernization, our goal is to bring more kind of ease of use of the business critical application by providing a modern database technology solution, like especially bringing in purpose-built databases that is available in the AWS for make the application much more usable and accessible, like and scalable easily through the application. And the second focus area is like a modern data platform. In modern data platform, our goal is to bring like a data foundation to our customer who looking to kind of move towards AI and ML strategy, like primarily to kind of bring all the data from different source system in the organization to put together in one place, so we could able to easily accelerate our reporting strategies, or AI strategies, or ML strategy area. And third focus area is like advanced analytics and ML. In this area, what we're focusing is to provide reporting adoption strategy. So what we're seeing like in the last 10 years, like in working towards the reporting area is either the customer used to have like a 10,000 reports where any business could not able to get direct answers from the reports, or like they have Excel spreadsheets that's running around where they use it to kind of get the answers on themselves. So as part of like our advanced analytics solution, what we wanted to do is use reporting and dashboard strategy to kind of provide the actionable insights just by looking at a simple screen. And in doing it, we leverage AI and ML part of our reporting to kind of easily see what's happening and also see what's going to happen part of our data patterns. And fourth area is like a business transformation using AI. In this, our key goal is to provide a quick implementation through our AI by using either pre-built services. In cases, customer needed a tailored solution. In that case, we use custom machine learning model to provide that particular type of solution. And the next slide that we're gonna look at is the case study overview. So before we getting into details of the case study, we just wanted to give a quick overview about the customer. The customer is like a logistics-based customer, and the revenue is like 3.9 million. And what they do today is primarily brokerage-based scenario where they take a customer shipment and move the shipment from one location to the another using carrier as a medium. So carrier is a transportation company where our customer directly work with the brokerage, customer directly work with the carrier in order to deliver the customer shipments. In doing this, they get on a day-to-day basis multiple questions from customer, carrier, and also internal operational system. So operational users where they have to answerable back both to customer and carrier. So they send this request back to analyst, and the analyst will understand the question that being asked by carrier or customer, and then they will go back and look at what are the different data available in different source system to provide the answer back to the operational user or any user that they are asking the question. And some of the challenges that logistics industry have is like since they are largely growing, they introduced multiple systems in the organization. So the analyst had to literally go to like almost 10 different systems to understand what is happening in order to provide answers back to the operational user. For example, the customer can come back and ask them, hey, can you provide me last month the list of shipments that we did and invoices that you raised, and which are the invoices that we already paid. So they have to go to the TMS system, they have to understand the finance data and club together, and they have to provide the details back. So as an analyst who joined the organization, they had an expectation to kind of do much more complex type of initiative, like they wanted to do ML and AI type of work, but they ended up doing like a SQL query on a daily basis in order to provide these answers. So they literally spend, in our case, this customer, the analyst group literally spent like 40 hours in a week in order to give answers back to individual operational users, and customer and carriers. So this covers like what the customer had a problem and how we solve this problem and what's special in this. Like Sid will provide the overview of this particular use case. So
Yeah. So when looking at what was actually special with this implementation versus, the other implementations we've done at Zeb and just generally other AI implementations, one aspect that comes to mind is the self-service capability we were able to bring in. With this implementation, we were able to bring in a full self-service flow with no manual intervention required, which enabled real-time operational efficiency for the client. But to dive a little bit deeper in this, usually when we talk about these implementations or when we talk about bringing something new in, like a new technology in, this involves working on a new portal or having operational end users working on a new platform to actually interact with this technology in. But we didn't want that to be the case with this implementation, and we wanted users to feel comfortable from their past experience and what they were already doing prior to this. And prior to this, they were just sending messages in a Slack channel to a data analyst to get the report through and processed by the data analyst. So we wanted to keep the exact same aspect. And so all of this is done through a Slack channel with the client interaction and the model interaction completely done and orchestrated through Slack. The other aspect that was really unique with this implementation was the natural language processing ability we were able to bring in. Especially within the logistics industry, there's a lot of company words and jargon that's used. And usually that involves specific knowledge in the logistics industry to understand requests, which means our model has to know what the user is talking about before I can even give the SQL query of the report that they're looking for. So this involved having to fine-tune the model by feeding it the pre-existing queries and reports that users had, and the actual SQL query that the data analyst did for that user's query, and training it on that information. And then once trained on that information, then having it be able to understand the user's request and associating to what that actually means. And lastly, I think I already touched upon this earlier, but the operational efficiency we were able to bring in, which was successfully being able to use GenAI to mitigate the work being put on these two dedicated data analysts and have them focus on more complex tasks. I'll get into actually a bit more number specific on this operational efficiency in the next slide.
Yeah, and the common thread that you'll see through, what made this solution special was really the fact that, from a change management aspect, which we believe is truly very core to any time we implement AI in an enterprise, we look at change management as one of those core pillars. And that's really something that makes us different. And it's something that's enabled us to have a lot more success implementing AI in an enterprise world as well. Not changing the way that they work, ensuring that operational users have direct access to it, see direct results on a platform they're already used to, makes all the difference and gets, stakeholders, especially on the business side, much more excited and invested in AI as a solution. So with that said, Sid will go a little bit more into some of the metrics and efficiencies that we've achieved through the solution.
Yeah. So when looking at the actual technical metrics, right? I know we see this number like model accuracy with the 98% next to it, but when diving deeper and trying to understand what does that actually mean, for us, this is a critical number as this exactly determines what solution we go with. And to give it a little bit more background, this 98% actually defines, we took a training set to train the model on historical requests with the queries that the data analyst created for those historical requests. We also took a test set at the same time, and which we then used to evaluate the model, basically creating a custom in-house benchmark for this specific use case. And with that benchmark, we were testing different models like Claude 2 by Anthropic, the one you see on the screen, and then other models like Llama 2 by Meta, and a defog model, which was a fine-tuned star coder model, the most popular code generation model, and that was fine-tuned on specifically text to SQL tasks. So we had to go through all these different iterations to understand what solution worked best for us. So initially, before Amazon Bedrock became generally available, we wanted to look at using SageMaker with the defog model that we saw, because we saw that defog model was performing best, and we saw we could improve that performance by training it, fine-tuning it on these specific reporting requests. And that's what we initially went with, and that was the first implementation we did. But then once Amazon Bedrock became generally available, we then tested using Claude 2 by Anthropic, and we saw that was delivering a model accuracy of 98% against this benchmark, which then altered our solution, and we instead went with using Amazon Bedrock and using this foundation model instead. When looking at the operational efficiencies, we were able to save 92% of the man hours being put into these reporting tasks, with having, mostly all the reports covered by the large language model. And we were also able to save 53% of the cost that was being put into actually these reporting requests, because again, the data analysts were focused on more advanced tasks, while the model was the main thing working on these tasks. And finally, the last thing we wanted to cover in the operational efficiency was the 72% uptick in reports that were actually getting generated. With this implementation, we had many users feel more comfortable with actually using this, as they were getting their reports back on time. And so we saw a large increase in the number of reports that were getting generated. To summarize, we were able to eliminate our clients' backlog of operational reports, while allowing two dedicated reporting resources to focus on more advanced tasks, thoroughly enabling significant operational efficiency and delivering, once again, a full self-service flow. Now Francis is going to give a little bit more background on Amazon Bedrock and why to use it.
Thank you, Sid. So my name is Francis Dogby. Amazon employee. I'm a PSSA, actually partner solution architect, covering some of our territories within Texas and Texoma region. And I've worked extensively with Zeb that have built these innovative accelerators and deployed actually in the field for our customers. So question here is why Amazon Bedrock out of all the numerous GenAI solutions that are there? And I want to dive a little deep into that. Amazon Bedrock is a fully managed service that makes a range of powerful foundation models from Amazon and leading AI companies, including AI21, Labs, Anthropic, Cohere, Meta, and Stability AI, that are available through a scalable and reliable and secure API consumption. With Bedrock's serverless experience, you can quickly experiment with FMs, foundation models. You can privately customize these FMs with your own data and easily integrate and deploy them into your applications using familiar AWS tools and capabilities without managing infrastructure. And that's a game changer for our customers. The fact that you can just go and not have to deploy large footprint of infrastructure, heavy compute to handle your models for you, and take a foundation model that we make available for you. It helps speed the time to innovate, like we have seen Zeb done for our customers. Also, we have agents for Amazon Bedrock that makes it easier for developers to create generative AI-based applications that can complete complex tasks and respond with more accurate and relevant answers using retrieval augmented generation RAG. And you see how all these capabilities have been leveraged by Zeb in building this powerful solution for our customer. Next slide, please. Okay, so the last thing I want to cover here is the the choice that is made available for customers to be able to pick and choose, customize an FM model that fits their business needs. We believe in offering the best choice and the flexibility of foundation models for your specific use case. We have our own Amazon Titan model, which include Titan Text for text summarization, and our Titan Embeddings model for embeddings and search. We offer AI21 Labs Jurassic 2, which uses natural language to generate text in a variety of languages. Also, Anthropic's Claude is built with the latest research on responsible AI to perform conversational and text processing tasks. When you come down to command, you can also see that command Cohere's large language model, LLM, is a text generation model trained for business applications such as summarization, copywriting, dialogue extraction, and even Q&A, question and answering. Fine-tuned versions of Llama models from Meta are ideal for dialogue use cases, and this is also exposed to the Bedrock, Amazon Bedrock framework. Bedrock also supports Stability AI's foundation models, including the widely popular Stable Diffusion model, which is capable of generating unique images, art, and designs. Now, Zeb is going to walk us through how they leverage these capabilities within Amazon Bedrock to provide a scalable, this is not experimental, a scalable solution that is actually deployed in production for our customers. Over to you, Ranjit.
Thanks, Francis. And as Sid mentioned earlier, like about the overview, like any like a user, like our operational user, like our carrier or a customer, like in our existing case study, like what we see is they used to have an interaction in the Slack channel. So what we did, part of the initial case study is we reused the same aspect where we retain any user could just go and post a question in the Slack, and we wanted to retain the same user experience and provide the response back to the kind of operational user. So like part of our case study, like what we did is like we took all the questions that they have asked in the last 2 years and kind of understood what are the different patterns of question being asked and what is the language that being used, and we trained the model specific to it. So if you when you see like AWS SageMaker inference, so what it add is like it add a custom build model where we have trained by using the existing questions that are being asked by all the user, and we trained the model and like fine-tune specifically to provide answers to any question that being asked by the user. So basically it understands the question asked by the user. We have provided the database structure of how we need to understand the table and columns. And based upon the question being asked, we provided a SQL queries that need to be provided as a response. So based upon this 3 information, the model is completely fine-tuned to provide the answer. So anytime we ask the question, it basically converts a text into a SQL query and provide the results back to us. So with this particular model, so any question that being sent by the user, we use AWS Lex chatbot in order to understand the natural language processing. And based upon the question that being asked and keyword being used, we trigger the Lambda function, and the Lambda function will send the information back to our model that sits in our AWS SageMaker inference. And from there, the queries get generated through our model, and then the query is sent back to RDS instance, and the response will be stored back in the AWS S3 bucket, and then that is sent back to Slack channel to the user. So user could able to just click on the URL and download the file which they needed. And we also add one more option, part of our Slack channel, is that they could able to ask, like, can you provide the report in a visual shape? So they can ask, like, can you provide me the bar chart of a particular scenario? So it just respond back the result using the bar chart in the quick site. and they could able to just click on the URL and provide response back to the user. And all this conversation, any question that being asked, any of the result that being provided, every step of this request and response has been captured part of a DynamoDB, so that we could able to see if any questions are not being answered, we can able to go back and retrain the model accordingly. So this is what we have initially started as an implementation. So now Sid will talk about how we transition from AWS SageMaker into AWS Bedrock.
Yeah, so when looking into how we transition this architecture from the SageMaker implementation to using Bedrock instead, you would notice that relatively the client interaction part stays the same, which you have the user interacting with the Slack channel, Slack interacting with Amazon Lex, and then Amazon Lex interacting with the Lambda function. The only change now being is instead of the Lambda function interacting with the SageMaker instance, it's now interacting with the Bedrock model. And Bedrock would then in turn communicate to the specific model that we're referring to, which would, in this case would be Claude 2. And that's the main change from the previous architecture. Once again, the model would generate the query, and then with that query would hit it against the RDS DB instance to then get the retrieved data, convert that into a CSV file, and upload that once more into the S3 bucket, and return that S3 bucket URL back to the user to download for their downloading purposes. And so this data processing layer also stays pretty much the same from the previous architecture. And once again, the QuickSight scenario, that also is very the same from the previous architecture as your user. The only difference from the previous flow would be that instead of the retrieved data being converted into a CSV file, it would be the retrieved data would directly talk to the QuickSight with the bar chart template or whichever template you're using, and then return that QuickSight URL back to the Slack through AWS Lex. So this is the full flow. But one thing I want to highlight here is that for your understanding is that Bedrock is not a replacement of SageMaker, but rather they're two different services for two completely different purposes here. In our case, the way we used it was, SageMaker is a full end-to-end model creation and fine-tuning platform, which means you can build, train, deploy, fine-tune your model all on SageMaker. Whereas Bedrock is really Amazon partnering with other companies as well as offering their own sophisticated models and allowing us to interact them on a one-stop shop basis. So giving us a few options to select from and then interacting with any of those models. So as you can see, there's a large difference between the two. We were able to use it in more of a plug-and-play situation, but that may not apply to every solution. So with that said, we're going to actually move into the demo phase of this architecture, and first show the and then we're going to show how exactly this is all working for your view.
So this is our interface which client typically use to ask questions. So what we're gonna do part of a demo is we're gonna take like a simple, medium, and complex type of use case and kind of show you the different aspects of it and how we could able to retain the conversation and ask questions on top of existing question as a follow-up. So as soon as I initiate this, so these conversations are fully handled in the Lex. So Lex is trying to provide the full details back in the Slack, and we have used a default data connector, so the Lex connector into the Slack channel, and we could able to post a question directly. So I'm going to ask like to provide the booking details with the booking status. And once I ask this question, so this request is being sent from the Slack channel to the Lex, and then like Lex will send the information back to the Lambda function, and the Lambda function will kind of send the question, and then the user context who is actually kind of logged into the system, and with both the details, it will also provide the database structure and with all the three information sent back to the model. So now the model will understand what is a question that's being asked by the user, and it generates a SQL, and that SQL is sent against our RDS Postgres instance, and it will respond back the details in the kind of in the S3 format. And this detail is stored in the S3. So I'm going to click on it quickly to download and show you the details. Just a minute. So as soon as I initiate this, so these conversations are fully handled in the Lex. So Lex is trying to provide the full details back in the Slack, and we have used a default data connector, so the Lex connector into the Slack channel, and we could able to post a question directly. So I'm going to ask like to provide the booking details with the booking status. And once I ask this question, so this request is being sent from the Slack channel to the Lex, and then like Lex will send the information back to the Lambda function, and the Lambda function will kind of send the question, and then the user context who is actually kind of logged into the system, and with both the details, it will also provide the database structure, and with all the three information sent back to the model. So now the model will understand what is a question that's being asked by the user, and it generates a SQL, and that SQL is sent against our RDS Postgres instance, and it will respond back the details in the kind of in the S3 format. And this detail is stored in the S3. So I'm going to click on it quickly to download and show you the details. Just a minute. So now you could see the download is happening from the browser. And when we click on the file, it will bring up the report. So this gives us full details about the booking ID, and then like carrier detail, and also with the kind of booking status. So as the next step, what I'm going to do is I'm going to take this example, and then I'm going to ask like a follow-up question saying to provide the customer name, and also to provide the carrier name of this particular booking details. So I'm going to continue the conversation and post the follow-up question and say like include the carrier name and the customer name. So now what it's going to do is the same flow on top of it. It just take the previous history of the conversation that happening in the channel, and then like send all the information together back to our model, and model will understand the full conversation history and generates the report. So this will provide us the result that we needed. So it's gonna come up in a minute. Yeah. So it included now the carrier name and the customer name on top of the existing result. So what I'm going to do on top of it is I'm going to ask question to specifically provide a little more complex type of example where the model has to write a logic to provide margin details for a particular customer. So I'm going to go back and ask a follow-up question. So now with going and understanding all the columns that is exist in the table and database, and it tried to generate the query by understanding the keywords which we provided, and it's gonna provide the results back to us shortly. And this overall response is based upon the query complexity and the RDS execution time. The response will come back.
And this is a really good example of where, understanding the operating model of a company is so critical, because, every logistics company can calculate margin differently as well. There could be different parameters they factor in, or they could be storing reference values in different places. So that's very critical. And that's part of our training process of the model that was explained by Sid a little bit earlier.
Yeah. And so as the next example, what we're gonna do is we're gonna use like a visual type of question and ask model to provide visual example of the particular data. So in this case, the only difference is after generating the query, we are sending the request back to QuickSight, and we basically generating 4 different components in the QuickSight, like creating a data set and creating the analysis layer, creating the visual, and then we are creating a dashboard. So by combining all of this, it'll kind of go and create the detail in the AWS instance. So when you click on the URL, like it automatically try to pull up the dashboard, which is generated kind of dynamically. So it will provide the results back to the users based upon the question that they asked. In this case, we have asked a question to provide the number of customers against a customer country, and this given the detail the specifically to the number of customers against the country. So this covers our demo aspect of it. And if you have any
one of the things you can see here with this example is this is a game changer for operators, because when they're getting questions from customers, they no longer have to wait on a data team to go generate a visual. This is something that they can immediately generate screenshots, send an email right away. So speed of service is totally changed. And customers are able to immediately not only just hear from a logistics company or from any company for that matter that they're technology forward, they're actually able to see that, and that makes all the difference. So like Ranjit said, this pretty much covers our demo and the content we had to show you today. I think we have a few minutes left for Q&A, so feel free to drop any questions in the Q&A section, and we'd be happy to answer them. Yeah, okay. I got a question in the chat. So I think this is for you, Ranjit and Sid. From the time of building the data foundation to actually executing this model, could you describe some of the challenges that you encountered?
Yeah, I mean, one of the biggest challenges with all of this, right? And specifically, I'm more referring to our SageMaker approach, right? And with that is when you go with fine-tuning a model, you often, I mean, not often, you pretty much always require a lot of data, which means a lot of data to actually train the model on. So when we were going with this approach, we had to really request a lot from our client and request a lot from the clients we're working with, to give us all the historical requests that were done previously, whether that even dates multiple years back into the past. So this is always a critical challenge, as some of the less matured companies, when they're trying to implement solutions like this, they often are not exactly AI ready specifically, as they don't have all that historical data to use. So this is a critical problem we continuously face when trying to build out these solutions. Luckily, with this client, they did have a large set of historical data we could use from, and enough to even build a test set to then evaluate the model on.
So Sid, I have a question for you and Ranjit.
Yeah.
How repeatable is this solution in terms of taking this? I know you guys used to have a lot of customers within our districts, and you're doing this for one customer. How repeatable is it for you to take a Gen AI solution like this and repeat it for other customers and scale it?
Yeah, really good question, Francis. I mean, it's definitely a very scalable solution, along with a very customizable approach, right? Because there's one really moving factor in this, which is the historical request that we're using to then train the fine-tune the model on, right? So this was trained in the logistics industry on logistics requests. Now all it's really a plug-and-play scenario is, okay, instead of logistics, we can then focus on different clients, and different client client's historical requests and then take that as an example. So that part is, completely remaining the same. And when coming to the scalability, well, scalability is all completely handled on Amazon as part of when going with Bedrock, there's no scalability even involved as they handle all the concurrent requests coming into the Bedrock service. So there's no issue on that side. And when looking at SageMaker, you can even scale up the resources you're using to host the fine-tuned model on all within the AWS console. So really involving no, infra person specifically to be, involved in this, and us developers can go in and manage the scalability of this completely.
And like Sid said, this is a very repeatable solution now for logistics, but we're taking a very verticalized approach to this. After we've built out the foundational structure of a solution like this, now we're applying that and applying the same operational background and knowledge we have to other industries we've already worked on, from healthcare to retail. A lot of the jargon, a lot of the approach, and a lot of the questions that people are going to ask. I think one of the key aspects we have at Zeb is the fact that we can harness 15 years of experience operationally across all these clients to generate that very cohesive and expansive training set.
I hope that answers your question, Francis.
Thank you. Thank you.
Yeah. I also have a question in the chat here from Gayatri. What happens when there's a spelling mistake in the prompt or when an irrelevant prompt is sent? Yeah. I mean, this is another really good question that a lot of our operational users also, wonder. So when there's a spelling mistake, a lot of these models are a lot of the foundation models offered by Amazon Bedrock are very sophisticated. So they are able to interpret the message even beyond the spelling mistake that's given, just due to the way they're how sophisticated they are. And in their training sets of those large language models, they would have already seen those, spelling mistakes come up and how to handle them. But when there's an irrelevant prompt and something that's, nothing to do with what's actually being asked out of the user, that's the whole reason we're using Amazon Lex, which will then we have fallback cases in play. So when the intent is not answered by the user, when the intent is not fulfilled by the user, we have a fallback like automated script to run to basically tell the user to either could you provide more detail or correct the response that they're sending in. I hope that answers your question, Gayatri.
Yeah, and top so anyway, the analyst is still sitting as a backup. So any question that it could not able to understand by a model, so the question will be sent back to analyst as a fallback, and analyst will review it and they will send back. And the moment we know that pattern coming and the analyst engaged, so we will also get a notification that the analyst is being engaged. And next time we will improve our model by providing the appropriate details. So the next time that use case get covered automatically.
And then finally, one more question from Ranjit P on how does GenAI handle data security and privacy concerns in the context of self-service reporting? This is another good question, and especially within the logistics industry and the reports going out, data privacy was one of our clients' #1 concerns that they had. And this was really answered by Amazon itself, because we implemented the solution within the client's Amazon environment, AWS environment. So it was not something that we controlled or anything like that. And when going with Amazon Bedrock, a solution that, partners with other companies, there are security policies that ensure that Amazon follows that ensure that the data that's being used with those foundation models is not then later used for training or sent back to the third-party providers.
One of the other aspects that were added to this was, we're providing organizational context to the model as well. And that's a very key thing. We are ensuring that the hierarchy of data that is actually surfaced back to the operators is in context of who they are. For example, if they were on the international brokerage team, the data that they're seeing is only international data versus, someone who's on the LTL team, for example. So that context of who the user is also passed into our model, which allows us to control the access to data that a user has.
Yeah. So hope that answers your question, Ranjit P. If there are no more questions, I think Mal, anything else from your side?
No, I think we can wrap this up. Thanks so much everyone for coming. We're very likely going to do one of these again pretty soon, but the recording for this one will be published on social, so you'll have access to that, and you'll have access to contact us if you can, and you can reach out with any additional questions you may have that come up in the future. But thanks so much for joining, and hope you have a really good Thanksgiving.
Yeah, happy Thanksgiving, everyone.
Thank you. Thanks, everyone.